Okay, so I'm going to go through just some things you need to be looking at to prepare for your test. So, test is tomorrow. If you're in my B-Day classes, test is Thursday if you're in the A-Day classes. So we did a couple different things this unit for the quadrilaterals unit. So I'm just going to go through some of the things that you should have in your notes. If not, you want to pause this video and kind of write these things in. So we went through all the shapes and actually took some measurements of each of the shapes so that you could tell which things are supposed to be congruent. So the exact angles aren't the same for every trapezoid, but you could look at, like, okay, on this trapezoid, none of these angles were the same. None of the corner angles are the same. On the isosceles trapezoid, two, what we call base angles, are the same, and the other two base angles are the same. Also on the isosceles trapezoid, the whole diagonal, diagonal 1, is equal to the second diagonal, diagonal 2. Okay? And then there's some consecutive angles that are supplementary, so these two things add up to equal 180, and so on. So for the parallelogram, same thing, there's some properties of different shapes. So you should be familiar with the shapes and some of their properties in order to do this test. And that's just kind of background. You should recognize, even if you have to visualize it in your head, like a rectangle has diagonals that are congruent. A rhombus does not. This is a much shorter diagonal than this. But the rhombus has all these angles are the same, these four. Okay. Kite looks like this. Square has 45s and everything, and it has 90s at the middle, and all the sides are equal. Okay, so we also filled in this property chart in case you weren't sure of some of the properties. So if you weren't sure, like looking at the picture that I just showed, which things are congruent or do the diagonals bisect each other, things like that, then you would look at this kind of reference. Again, if you don't have this already filled in your notes, then you want to fill this in just so that you are familiar with what things should be supplementary, or which things bisect each other, which things are congruent, like which kind of sides are congruent, and so on. So these two things are good resources for knowing the properties if you don't know the properties yet. And there will be a couple questions like the beginning of our packet 1, where it's solely based off you knowing the properties. So you're basically matching the parallelograms or the quadrilaterals with their properties. Things like, are the diagonals congruent? Do the diagonals bisect each other? Are the corner angles supplementary? Things like that. So you want to be able to do that, and we went through that in each of the classes. So the answers for all these, I also posted online underneath the class notes and resources. I just want to go through a couple of the things that just are some things you should recognize when you're doing these. So we did all the proofs together in most of the classes. So I'll just pick a random one to do, a couple random ones to do so you can just see the steps. And then I'll do 19 through 21 because I did not get to that in every single class. So number 6, and that's just, again, a random pick, they give you some information. That all should be the reason for those pieces of information as statements is given. And then whatever you're trying to prove, that needs to be what you end the proof with. Okay, so I'm just going to focus this because it keeps bouncing around. Okay. So if they tell us that N and A are right angles, that's given. And then N and A are congruent. Angles N and A are congruent. Well, it doesn't tell us here. This exact wording is not written here. So this came from either the picture, sometimes the picture, or sometimes the statement. So if they're both right angles and they're congruent, that's because all right angles are congruent. So because they're right angles, every right angle is 90, so they're all equal to each other, which congruent means equal to each other. The other piece of given information was that I is the midpoint of PT. So in segment PT, I is right in the middle, which makes two things, by definition of midpoint, two things equal. So we don't have anything with A in this particular part, or N. They only care about PT's line, and I is the middle. So that means that IT and IP will be congruent. Okay, so we can mark that on our figure. And you want to mark your figure because that'll help you determine how the triangles are congruent. The N and A were already marked, so I didn't have to do that part. Okay, then they say angle TIN, so the symbols are important because this is different than the whole triangle because it doesn't have the triangle symbol. So angle TIN, this angle is talking about angle I, so it's always the middle letter that it's referring to, with the two rays being the other two connecting points. So N and T were the 2 points that you're talking about. So it's saying I, but with the boundaries of NI is one side and TI is the other. That lets us know that we don't go past I for the angle out here. We stop at T and we stop at N. Those are the 2 rays we stop along. And then AIP is this other angle, again, starting at A, going through I and P. It's really talking about angle I with A as one of the boundaries for the rays and P is the other. Well, AI and PI. And those are called vertical angles, 2 angles that are across from each other when lines intersect. So now that I have mine marked, I can tell that angle, angle, side matches angle, angle, side. So these triangles are congruent by angle, angle, side. Okay, if you need to go through that, pause it, reflect on it. I also want to do one that has the alternate interior. So this one was a good one because it covered both midpoint and vertical angles. This one's a good one because it has the other ones, the reflective property alternate interior. So if O and H are parallel, OH is parallel to EP, those 2 lines are parallel, then the alternate interior angles on those lines. So if I were to draw a set of parallel lines called OH and EP, then I have a couple different transversals I can pick. I can pick HE as my transversal, HP or OP. If I picked my transversal as HE, then my alternate interior angle would be outside of my parallelogram. So I want to pick this as my transversal, HP, which makes my alternate interior angles these 2 angles. And I have to name these angles because they're telling us to name the alternate interior angles. So H is the vertex, so I need that letter in the middle. And then the boundaries on the other sides are O and P, so my name would be OHP or PHO. And that's congruent to, in this angle, P is the vertex, so P needs to be the middle letter. And then you can either start with H and go HPE, or you could start with E and say EPH. Those are the same angle, just a different name. Okay, so I can mark that on my figure. Then EH is parallel to OP. That's already marked on there with the arrows, which means that PHE, again, this is angle H with the boundaries of HE as one side and HP as the other side. So I have to stop my angle here. I'm not going all the way to the corner. And HPO, same deal. And these are alternate interior angles for their lines. So if I just turn this, I will have to rename my points. Actually, I have to redraw it because my diagonal line is going the wrong way, so I will redraw it. So if I just draw, I'm messing up. Okay, if I do HE and OP as my 2 parallel lines, my transversal options are this, this, or this. I'm going to choose this one because it gives me alternate interior angles inside the parallelogram. So those were the 2 angles we identified with 2 angle bends each, which are these. These are alternate interior for those other parallel lines. Okay, the reflexive property is probably my favorite because it's easily recognizable. It's the shared segment or angle, but in this case, shared segment. So HP is on both HOP's triangle, this full triangle, and HP is on HPE's triangle. So HP is congruent to itself, and that counts as a side for us. So now looking at the markings we have marked on our figure, these don't count as sides because they're arrows and not tick marks. So only tick marks count as sides. Arrows mean parallel. So this is angle, side, angle. So the 2 angle bend, the 1 side mark, and the 1 angle bend matches 2 angle bend, 1 side mark, and angle bend. So angle, side, angle. And that's it for 7. Typically, when you have one of these angle, side angles, side, 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 side angle, side, HL, the next statement is going to be a corresponding part. So it's that CP-CTC follows it. This one we didn't have to do it because we were just proving the triangles congruent. But in a lot of these, like looking at number 15, for instance, we have this side angle side. The next statement needs to be that CP-CTC. which is the corresponding parts of the congruent triangles. So this is saying two triangles are congruent, so we're going to have triangles here being congruent. Then all their corresponding parts of congruent triangles are congruent. So I see a CPCTC here, which means right before it needs to be one of the 5 ways to prove triangles congruent, which it is because the triangles are congruent here on 10. I see triangles being proven congruent here, so I know this last statement is going to be CPCTC, even if I don't know what this way, which are the 5 ways it proves it congruent yet. Okay. And then, like I said, I want to go over 19 through the 21, just because we didn't get to in a lot of the classes. This one, the putting in order is not on the test, because really there's a multitude of order arrangements you could have. The key for 19 is that you put the first thing first and the last thing last. So out of 8 boxes, RSTU as a square needs to be the first statement. And then RT perpendicular, crossing at 90 SU, has got to be the last. Then for a square particularly, there's so many things that are true about a square that you could go up in almost any order for the rest of this stuff. So if RST is a square, then I'm going to go to the reasons and look for something that says something that breaks down what it means for it to be a square. So one of these 2 things I would put next, because it says definition of a square, all the sides are equal. So I'll put this as 2. I could have also put this one as 2. And in a square, diagonals are congruent and bisect each other. So this is 3 or 2. So if I mark that on my figure, before I go on to the next step, then my next step I would go to is that these triangles are all congruent by side, side, side. So I would put 4 next here. Again, these statements are true, so they can go next, but based on just going with the flow of the proof, I would go with side, side, side next. So if these are all congruent, what usually follows SSS is CPCTC. So UVR, all of these angles are congruent, because they're all corresponding. They're all between the 2 congruent sides of the side, side, side triangles. And if those are all congruent, and anything that makes a straight line, like a linear pair, is supplementary, then they're each going to have to be 90. Okay. So that's one order that you could have put them in for 19 through 20. For number 20, kind of let the reasons guide your statements. So diagonals of a rhombus are perpendicular. So we need to figure out what are the diagonals, and we need to write them as perpendicular. So the diagonals would be DB and AC. Definition of perpendicular, what does that mean to us? Well, that means that the angles are congruent. So all of these are going to be 90-degree congruent angles. So that means the measure of angle DEC is equal to the measure of angle CEB, and they're both 90. All of these angles are 90, but I only wrote 2 of them because I already kind of know this proof is going towards proving this triangle, DEC, congruent to BEC. So they're not actually so concerned about what's going on over here, even though these also would be equal to 90. Okay, if they both equal 90 and they're congruent, that's the definition of congruent. So anything that's equal, if they're equal, then we can say that they're congruent, and vice versa. And so when you do that, when something's equal, it goes to congruent, or congruent to equal, then it's definition of congruent, which spelled out as congruence a lot of times, but we just put congruent. Okay, then DE is congruent to BE. I would look to see if that is information is being deduced from any of these previous steps. And if it's not, then I just think about what is a rhombus? What are these parts on a rhombus? So this is the diagonal pieces. And a rhombus properties, one of the properties is that the diagonals bisect each other. So the diagonals are cutting each other in half. So the diagonals are bisected in a rhombus. Okay, they can write that a bunch of different ways. They could put definition of or property of a rhombus, diagonals bisect each other. Bunch of different ways they can write it, but you're looking for diagonals because they're parts of a diagonals being bisected, cut in half. Okay, reflexive property would be EC for this problem because these are the two triangles we're comparing. So sometimes you will have to look at where you're headed to kind of know which segments, because there's a lot of reflexive property segment potential in this problem. But we would pick EC because that one is a part of the triangles that we are looking for in red marker or pen. Okay, then these triangles are congruent by side angle side matches side angle side. Then CPCTC follows. And the corresponding parts that we need to prove that AC, this segment, is acting as the scissors cutting angle DCB in half. So if I take my scissors here and I cut right here, then the angles that need to be congruent are these two. So really what they want us to prove, even though there are 3 corresponding parts left in the triangle, since we've only proven 3 out of the 6, technically these are corresponding parts now, these angles are corresponding parts, and these. But we want these because this is the one that has to do with AC being as a bisector. So you'd say angle DCE is congruent to angle BCE, which makes it a bisector. This is a bisector by definition if these angles are equal. Okay, and then the last one on here. Most of the proof is filled out for us, so we just kind of have to read through it and mark things on the picture. So ABCD is a parallelogram. CBD is congruent to ABD. And BDC is congruent to BDA. So knowing how to name these angles and which angle they're referring to is super important for marking up your figure. Then they tell us BD is congruent to itself. So this segment is congruent to itself by the reflexive property. So the triangles here and here are congruent by angle, side, angle. Matches angle, side, angle. So all their corresponding parts are congruent, making this congruent to this. Sorry, this congruent to that, and these two congruent. Then they say opposite sides of a parallelogram are congruent, and we already know it's a parallelogram from statement 1. So that means AB is now the same as DC, so we need to give these the same amount of markings. It's easier to add one than to try to take a marking away here. And then these are also the same now, so it's easier to add one than to try to take a marking away. So, since those were congruent, now all of the sides are congruent. CD, AB, AD, and BC. And we know that because of substitution. Since these were congruent to each other, and this was congruent to this, I can substitute in this for anything, any of the sides, and they're all congruent. That one's a little harder because it's not like an equation you're substituting just one thing in. You're creating a new equation that has all of them congruent. Okay, so but that's the proofs. So there'll be 2 proofs on there. Each of these blanks will be a problem. So you have 40% of the test essentially is getting these proof blanks correct. Okay, then you have some problems about finding the missing angles, which is a lot of what your Math Excel is on. Please do the Math Excel if you can before the test, even though you have till the 15th. It says the due date's on there, but it'll let you click on it there till the 15th. But the point of that is because you want to be able to practice before the test. If you practice after the test, you'll have missed it on the test. So it's better to practice beforehand, but if you absolutely can't get it done tonight, you'll still have a couple of days to do it. All right, so properties of parallelograms. So this is when I would use this sheet if I was stuck. Okay. So, for instance, on a parallelogram, I would relate a plus 15 is a side. On a parallelogram, I can relate sides to, let's see if I can relate it to anything. So looking for something that says sides on here. So there's congruent sides, meaning I can set things equal, so I would use that one. There are 2 sets of congruent sides. Looking at the picture, these would be congruent, these would be congruent, so I can just set this equal to this. and solve for A. Okay, other things you might look for on a parallelogram, if I wanted to relate these two, since they both have y in it, those are consecutive or adjacent angles. So I look for something that says consecutive or adjacent on any of these columns, and I see adjacent here, and it says adjacent angles are supplementary. So that means that these two angles should equal 180. Okay, so we're just using the properties to come up with the equations, either equal to each other, which means congruent, equal to 180, equal to 90, and occasionally you'll have to double something. So like on number 7. In a rhombus, BCD is talking about this whole angle is 80, because it didn't say BCA, which would be half of the angle, or ACD, which would be the other half. What is DBC, which is talking about just this part of the angle, so just half of this angle? Well, rhombus are parallelograms, so we know the opposite angles are the same, and then the other angles have to be 180 with the consecutive angles. So this would be 100 altogether, 100 altogether, which makes the half part. On a rhombus, these all four are equal. So this is when it comes in handy knowing your properties. These all four are equal, making these both 50. So this is a 50-degree angle. Okay, so you're using the properties for a lot of these to get the different things. Number 9, parallelogram has diagonals, which must be true. So BE and CE, we don't have anything relating these two because they're not on the same diagonal. So on a parallelogram, the diagonals are not congruent. So this diagonal is not the same length as this one. And the diagonals bisect each other. So that means that this part would be equal to this, and this would be equal to this, but these are all four equal, like they are on a rectangle or a square. So rectangle and square, all four of these are equal, but not on a parallelogram. So that's out. Angle BAE is equal to angle DCE. That's always true for anything that's a parallelogram because these lines are parallel, so the alternate interior angles are congruent. AB and BC consecutive sides are not necessarily the same on a parallelogram. This could be long, this could be short. The way they've drawn it here, it looks like a rhombus, but if I exaggerate it, you can tell AB does not need to be the same length as BC. And then DAE is congruent to CBE. These angles don't have to be congruent except for on a rectangle or a square. Okay, so a couple on the back. If we're looking at the square, okay, so if it's a square, and I go back to my property sheet, on a square, all of these angles are 45s. And that's because a 90-degree angle gets cut exactly in half. So a square is both a rhombus, so these are all four the same, and a rectangle where all four of these are the same. So I know that 9x, this whole angle, has to total 45 by itself. Because on a square, again, these are each 45s. So they basically want to know what number times x gives you 45. So we set 9x equal to 45, and x is 5. Okay. Same thing with z, just set it equal to 45 and solve. And then angle 1 is in the middle, and all of these are 90s in the middle, because diagonals bisect, the diagonals are perpendicular for a square, for a rhombus, and a kite, those three. So you would set this equal to 90. So put 90 in here and solve for y. Okay, on this problem on 19, these two are a corner of a rectangle, so you would add them together to equal 90, because they together should equal a 90-degree box. On a rhombus, these two angles add to equal 90 as well, because these four are the same, and these four are the same. But in a triangle, if you have a 90-degree angle, since the diagonals cross at 90, then the three angles in the triangle must equal 180. So 8x plus 7 plus 3x plus 6 plus 90 equals 180. Well, if I subtract 90 from both sides, then adding these two together, 11x plus 13 equals 90. So these two have to equal 90 since there's already a 90-degree angle. And then these are the same on a rectangle, all four of these. So these are just congruent to each other. So I'm going to post the answers. Like I said, they're going to be posted on the website underneath underneath class notes and resources for you to check your work to make sure you did these correctly. That's all packet 2. So that's about half the test. Then we have another 2 packets. So about 3 questions from each of these 2 packets. Okay, finding the length on this, what you're doing for the first part is you're using the distance formula and Pythagorean theorem together. So the way that you do that is we don't write out what the coordinates are because that is the A of your Pythagorean theorem. Okay, we don't write out the coordinates here. That's the B of the Pythagorean theorem. But you do start off with a square root symbol for the length between 2 points and figure out A and B. A and B are your horizontal and vertical shifts. So you can't travel diagonally. You have to travel horizontally and vertically to get from point to point. If I do that, my vertical change is 1, so B would be 1. And my horizontal change is 7, so A would be 7. So I do the square root of 7 squared, because it's A squared plus B squared, 1 squared. And then when I get that, my answer is the square root of 50. So for any problem, I can just simply count over and square that number, so the over part, and then up or down. Doesn't matter if it's up or down, you're just going to leave it positive because you're squaring it. The kids in the gym getting excited. So 9 is how many it goes over, and 3 is how many it goes up or down. So that's how you do those. So learning target 2 is finding the area or the perimeter. So you do need to, in our notes we have formulas for area and perimeter, so you need to make sure you have those in your notes, and you need to memorize those. So we'll do a brain jog activity right before, or just like a brain dump thing, so you can kind of put those on your formula sheet as soon, on your test sheet as soon as you get it. But the area formulas, you don't get on the EOC, so you do have to memorize those. Once you know the formulas, you're just basically finding which dimensions you need in order to fill in the formula. So if we do ones, we did those in class, so I'm going to skip those. If I do number 5 and 6. Area and perimeter of a rhombus. So area of a rhombus is 1/2 diagonal 1 times diagonal 2. That's just a formula that I have to memorize for rhombus. Perimeter of any shape is the sum of the sides. So it's the length of AB plus the length of BC, CD, and AD. So that means I need to find 4 different things. I need to find D1, what the length of that is, the diagonal 1, diagonal 2's length, AB's length, BC, CD, and AD. These 4 for the perimeter, these 2 for the area. Okay. So when I do that, diagonal 1 is made up of segment BD. So that's just one of the diagonals. And I don't care which one's diagonal 1, which one's 2, because they're going to get multiplied together. So I'm counting over and up, again, as my 2 numbers that go underneath my radical. 5 units over, 5 units up. So you can pause the video if you need to, but you're just counting over and up and squaring those. And then AC, same thing, counting over is 3 and up is 3. And you're adding 9 and 9 and 25 and 25, so that's how I get these numbers. Then I just take my calculator and I put in 0.5 times the square root of 50. I close it so that it only takes the square root of 50, it doesn't take the square root of 18. And it tells me it's 15. So then my area is 15 after I plug it in. And area is how much something covers, so it's really talking about this. So it's units squared. Okay, perimeter, you do it the same way. You find AB. A to B goes over 4 units up 1. So 4 and 1 are my numbers I put in here. 16 and 1 is 17. It's a rhombus, so if you know your properties of a rhombus, you can skip a lot of work. Rhombus have all sides the same. So technically I can just multiply one side by 4, or I can do it 4 different times. So the square root of 17 times 4 is 16.5. Or the square root of 17 plus the square root of 17 plus the square root of 17 plus the square root of 17 is 16.5. Oh, I just said all that and you couldn't see anything. I'm not retaking. Okay, so that's in units. It's not square because it's just walking around the edge, the distance along the edge. All right, number 6. Area of the trapezoid is 1/2 height times the bases added together. Perimeter of any shape is the sum of the sides. When I'm writing the side lengths, I don't put a symbol over it because this without the symbol means the distance from Q to R. So a lot of times on your Math Excel, it'll have the QR equals question mark. That means the length from Q to R, the distance from Q to R. So I need a couple things in here. I need the height. I need the base 1, base 2. I need QR and RS and SP and QP. I need all of those things. Okay, I wrote the square roots on there just because, but we might not use them. So some of these, if it's a horizontal or vertical distance, we don't need to do the square root thing. So if I look at how high this trapezoid is, it's 2 units. And I don't even need a square root. I can just see that it's 2. I can just count 1, 2 units up. Base 1, I can just make this my base 1 and count it because it's a horizontal line. I can travel horizontally and vertically, so I don't have to do any a squared and b squared with a horizontal or a vertical line. Base 2 is also horizontal, and it's 6. Okay, base 2 happens to be QR, and base 1 happens to be PS. So those don't have a square root involved in it. There was no diagonal side. On RS, I have to go over 2 and up 2 to get from one point to the other. So 2 and 2 are my numbers in my radical. So 4 and 4 is 8. And I can tell this is equivalent to this. So it's 2 and 2. So it's going to be 8. So now I'm just plugging in everything to the formula. And evaluating. 0.5 times 2 times 16 is 16 units squared. 6 plus the square root of 8 plus 10 plus the square root of 8 is 21.7 units. Pause it if you need to go back, rewind, whatever you need. All right, 7 through 7. So the perimeter area for a parallelogram, area is base times height. Perimeter is the sum of any sides. Okay, this one, the base and the height, this is the hardest kind because the base and the height are not already on the picture for you. If I try to make this my base, then my height would go from this point, dropping it down to perpendicular to this side. So if I do perpendicular to this, I look at the 3 because it's already got a segment on my ruler, and I just go like right here. And it happens to be in the middle of a coordinate. I don't really like that. So I'm going to try to use my other base of NP, looking at the tick mark on here, going to R. And it goes through a point. Again, I'm starting at any point that's not on the base. So if my base is NP, then I would pick R or Q to start at, and then just go perpendicular to NP's segment. So again, I'm looking perpendicular to NP segment going straight down. If I had done it from Q, I would have to do a little bit of an extension of my line, but it would be the same length as this because they both go over 2 and up 2. So they're going to actually be the same length. So my base is NP because that's what I drew my height to. So my base is NP, and my height was R, and I'll call this A. They're slanted distances, so I know that I'm going to be needing my square roots. Then NR is also a slanted distance, so I need my radical. NP is the same as RQ on a parallelogram. So once I get NP, I'll have RQ. Those are the same. And once I get NR, these are the same. So I really want to do it 3 times. You could do it every single time if you want. NP. So N to P, I need to figure out over and up how much does it go. 3 and 3. RA, 2 and 2. So you can pause this and go ahead of me and then come back and just check. Square root of 18 times square root of 8 is just 12. 512. NR is 3 and 1. Square root of 10. So we have 2 square root of 10s, NR and PQ. And NP was square root of 18, so 2 square root of 18s. So 2 square root of 10s plus 2 square root of 18s. It's 2 square root of 10s plus 2 square root of 18s. 14.8. Most of the learning target 4 you should be able to figure out because it just uses the formulas for perimeter area. But the last 2 on there, if he wants to paint a rectangular fence, typically you don't paint just the outsides of the fence, you just cover it, so it's asking for area. So you're going to be doing area formula. And the one with Christina lining her room with photos, just 1 line of photos per wall. So it means she's got like a line of photos here. And they're 4 inches wide, so in every foot, she can fit how many photos? You would figure that out. And then once you know how many she can fit in 1 feet, you multiply that by 15. And that'll be how many she can fit on a wall. And then she has 4 walls of a square, so they're all the same, so you just multiply that by 4. So that's some hints for that. Okay, so that's the second packet. So that's 3 or 4 questions come from there. And the final packet, you don't have to actually verify these on the test. You can just plot it and guess. But if you wanted to verify it, you can use distance formula to verify length, slope to verify parallel and perpendicular, and midpoints to verify bisected. So I'm just going to do a couple random ones that we did not do in class. Select number 9. So my guess would be a parallelogram. I can tell it's not a rectangle or rhombus. These angles aren't really that close to 90. A rhombus, it's not a rhombus because these don't look the same length. But I can verify that these aren't the same length pretty quickly. So if I wanted to check my lengths, so if I pick parallelogram or rhombus between those two, first I would verify the slopes. I want to see if my check for parallel is to verify the slopes. So I want to see if the slope of NR is the same as the slope of PQ. So from N to R, I go up 1 and over 1, 2, 3. And then P to Q, up 1, over 1, 2, 3. So slope is just rise over run. Sorry. And if we verify the other opposite sides, NP and RQ, I go up 1, 2, I go from 1 to 4, so up 3, and then negative 3 to 6, up over 3. Up 3, left 3. So it is a parallelogram, and it's not a rhombus because if I use these numbers as my distance formula numbers, so this would be my check for congruent adjacent sides, or consecutive, those are order interchangeable sides. I want to see if NR is the same length as RQ. Once I do the slope, I already have my A and my B of the distance formula / Pythagorean theorem. So 3 squared plus 1 squared is not going to be the same as 3 squared plus 3 squared, so they're not equal. So it's just a parallelogram and not a rhombus. Okay, since we're here, we'll do 10. Okay, off the bat, it looks like a isosceles trapezoid. Okay, so I can check to see if these sides are parallel. Because they're horizontal lines, they both have a y of 1. So I know that that's a horizontal line. And then EF, they both have a y of negative 3. So I know that the slopes are the same. I don't even need to calculate it because all horizontal lines are parallel. So I know that it's a trapezoid. And then I would check the lengths of DE and GF and make sure they're the same. So 1, 2, 3, 4. So it's like 4, 4. I can verify D and E. So in between negative 3 and 1 is 4 units, yes. And in between negative 7 and negative 3 is 4 units, that's correct. In between 2 and 6 is 4 units. In between 1 and negative 3 is 4 units. So if the graph is hard to read, you can just use the coordinates and just do how many units are between the x's and the y's. Well, they'll read the same number because it's the same 4 squared and 4 squared, so it's a isosceles trapezoid. But you can actually do the math out. All right. Numbers 1 and 2 we went over in every class. So 3, actually we went over 3 in most of the classes. In case we didn't go over it in your class. 3, if a square has the diagonals of FH at 2, 1, 5, negative 6, what are the coordinates of E and G? So the other two diagonals. So if I was not sure, and I didn't want to do all that work that we did in class to kind of go through this, then I would just draw basically a large plus sign. You need to be perpendicular, so you would want to use a ruler or a straight edge and line up one tick mark with FH's line. Then you need to go through the middle of this line, so you need to approximate the midpoint, which should look halfway between it, and then draw a diagonal line through that. So the answers are going to be around here and around here. So if there's choices, then you're done. You don't have to do all the work. But showing this step would help me know that you know why it's one of those. Okay, So F and G. So first step is to find the midpoint. So if we do the midpoint of FH, which again, the midpoint is the average of the x's and the average of the y's. So we add 2 and 5. Those are x1 and x2. Again, if I'm going really quickly, I'm just trying to beat the bell because School's going to be out in a couple minutes. And I want to be sure to post this video tonight. But you can always pause it, rewind, go back, slow it down, whatever you need. Okay, so midpoint at 2 plus 5, so it's going to be 7 halves. And then -6 and 1 is -5 halves, which is hard to grasp, so I just do it in decimal form. Which to get decimal form, you just divide it. So 7 divided by 2. And 5 -5 divided by 2. Okay, so my midpoint is at 3.5, comma -2.5. Then I figured out what the slope is from that to F. So the slope is rise a half, and then 1, 2, 3, so it's 3.5. And then I have to go left a half, and then 1. So my reciprocal perpendicular lines have opposite reciprocal slopes. I'm going to have a positive altogether. So I'm going to be going up a half and 1, then going over a half and 3. Another way to write 1.5 over 3.5 is to write them both as negative, because negative divided by negative gives you back to the positive. So you could go down and left, a half and 1, a half and 1, 2, 3. Okay, so your answer should have been 7, 1, and 0, -4. Okay, number 6. So you got your coordinates of a kite, -3, 0, 0, 2, 3, 0. K-I-T. What is the x-coordinate of the final point? So we know it has to be, since these two sides are already the same, these two sides are going to need to be the same. So we know the x-coordinate is 0, because it's got to follow on this line, which the y-axis x-coordinates are all 0. So looking at I, for instance, that's on the y-axis, it's got an x-coordinate of 0. The y-coordinate could be anything less than or down from -3. So if I put it at -2, it's a parallelogram. So these sides are parallel and these sides. So I don't want to put it at -2. But if I put it at -3, now these sides are longer than these two sides. So now it's a kite. So anything less than -3, we're good. Okay, and the rectangle on the bottom, this will be the last one. Okay, they're asking us to find C. So with rectangles, it's kind of hard to know, like, if C is over here, if C is over, like, which direction. Sorry, -4, +4. So it's hard to know if where C is, because C could be over here. Technically not over here because it's a rectangle, and that would make it a weird angle. So it's got to be over here, actually. But the name of it's going to help me know that A and C need to be opposite each other. So C needs to be opposite of A. So if this was 2 over and 1 up, then I need to be able to go 2 over and 1 up to get from, it needs to be the same slope. So 1 over 2 and 1 over 2. So C is going to be at -3, -3. Okay, so again, whatever slope this side has of the rectangle, this side of the rectangle will have to have the same slope. So if my slope is rise 1, run 2, or fall 1 from A, because I want to go from A actually, because that way I can start at B, since A and B would be the coordinating points. So if I start at A, my slope is -1, -2. So from B I would go down 1 and left 2. And that would tell me C is -3, -3. Okay, so study over those, and please try the Math Excel. If you have any questions, I'll be here in the morning, like 6:40 usually, and then I'll answer a couple questions right before the test, but that's it.